Okay, so let's talk about doing inverse trig using special triangles. And where inverse trig is just finding angles, right? Instead of side ratios, we find angles. So a little review. So remember, right triangle trig. So we have a right triangle, we have an angle. Sine is defined as opposite over hypotenuse. Cosine is adjacent over hypotenuse, right? So B over C. And tan is opposite over adjacent. So those are, remember, sine of an angle equals the ratio of two sides of a right triangle. Okay. We also developed some special right triangles. So if theta is 30, right? So this is 30, then this one has to be 90, or I'm sorry, 60, right? Because they have to add up to be 90. Well, opposite 30 is x. Opposite the 90 degrees, the hypotenuse is 2x, and opposite 60 is x rad 3, right? So we had those ratios given 30, 60, 90 triangle. We developed the same thing for 45, 45, 90, like, right? The isosceles right triangle. Opposite 45 is x, opposite for either 45 is x, right? Those two sides have to be equal. And then opposite the 90 degrees, the hypotenuse is x rad 2. All right. Okay. So that's what we developed so far. So what I want you to do is stop this and then complete the classwork problem, the review section, where I just want you to draw those special right triangles. Okay. So now let's use those triangles, those special right triangles, to evaluate what sine of 30 degrees would be. All right. So when you look at this, right, again, don't just see this as sine of 30. I want you to see everything it represents. So we have a sine, right, a trig ratio, which means we're talking about right triangles. Right? So as soon as you see sine, cosine, tan, you think right triangle. Okay. And now I have right triangles in sine. I know that sine is opposite over hypotenuse. Okay. So now that I have sine of 30, I know the angle somewhere in here is 30, and then the opposite side over this hypotenuse length, that's what this ratio or this sine of 30 will be. It'll be that ratio of sides. Well, luckily, we have a special right triangle, right? 30, 60, and then 90. So now, because I recognize it was sine and a right triangle, and I recognize it was 30 and it was a special right triangle, now I can actually fill in the opposite and hypotenuse. I can find this value. So what is it? Well, I'm going to get rid of the 60 part because I don't need any of that. Opposite of 30 is x, hypotenuse is 2x. So sine of 30 is x over 2x. Okay, all right. And so now all we need to do to evaluate this is simplify this expression. And what do? We divide out these x's. So I'm going to show you the steps. I'm not entirely sure we understand what's going on. So x divided by x, you can think of this as 1/2. So the numbers, right, there's a 1 out front. It's 1/2 times x over x, right? And so you can see 1 times x is x, 2 times x is 2x. Now this x divided by x, that equals 1. So that's why when you divide out these x's, it's not a blank on top, right? It's not a 0 on top. It's a 1 because x divided by x is 1. So sine of 30 is 1/2. All right. So we could check it on a calculator. So type in 30, type in sine, and you'll see it will be 0.5, 1/2. All right. Okay. So that's an example of how we would use a special right triangle to evaluate this trig expression. Right. And now what is this value, this 1/2? Remember, when you do sine, cosine, or tan of an angle, your result, the number is a ratio of sides. So this is a ratio of sides, specifically opposite over hypotenuse. Okay, so you want to stop this and do classwork problem number one. Okay, so now let's go the other way. What if I told you that sine of theta equals a number, right? Now, I didn't tell you what theta was. So now in this case, I'm giving you the ratio of sides, and I want to know what angle it came from. All right, so same thing. We have sine, so I know I'm dealing with right triangles. So let's throw up our right triangle. I know sine, again, is opposite over hypotenuse. That's right triangle trig. And now I'm actually given that sine is 0.5. But when we're dealing with ratios of sides, let's get a ratio. Let's actually get a fraction. So instead of 0.5, I'll make it 1/2. And now you can see opposite and hypotenuse. So opposite is 1, hypotenuse is 2. So I need a triangle where the opposite is 1 and the hypotenuse is 2, right? That ratio. Well, we only have two special right triangles. So which one is it? In the 30, 60, 90 and the 45, 45, which triangle do you see the numerical value of 1 and the numerical value of 2? Well, it's not x rad 3, that's a rad 3, right? Well, here are the two. That's nice. and here's an x. And notice there's actually a 1 in front, so that actually fits. Here's a 2 and a 1. Well, here's a red 2, that won't work. And here both are 1s. These are nice 1s, but the other part is a red 2. So it looks like this is it, right? Because I need opposite of 1 and hypotenuse of 2, opposite is 1, hypotenuse is 2, right? So 1x and 2x. So that's very promising. Well, let's see this then. Well, what would sine of this triangle be such that I had opposite of x and hypotenuse of 2x? It would have to be sine of 30, right? 30 would be opposite over hypotenuse, x divided by 2x, and you can see the x's divide out. So sine of 30 is 1/2. So just by going and being able to identify which triangle I'm using, I can play around with the trig ratios to figure out which order and which angle I need to be at, such that when I divide and reduce, I'll get this number. So if sine of 30 equals a half, then sine of theta equals a half means that theta has to be 30. All right. Okay. All right. So that's actually the end of the video. So you want to stop this and do class or problem number 2.